Okay, we're going to look at problem 3 in the chapter 6. Solve the centroid of this shape. And this shape's several different ways you can approach it, but first let's identify origin is given over in this corner. This is the x-axis, this is the y-axis. And you have basically a rectangle, and then you have two void rectangles or holes that you're punching out. So there's a couple ways to do it. You could break this down into multiple little pieces, this and this and this, and then have this and this, this and this, so you could get a bunch of them. Or you could take one big rectangle into smaller ones and we'll punch the holes out. We just consider these negative areas. That's what I'm going to do because it's a little bit easier to deal with, and it only gives us 3 shapes. So we're going to consider this outside shape as shape 1. We're going to call this little guy here, we'll make this shape 2. We'll make this shape 3. And shape 1, we'll call it the exterior rectangle. So we're going to first start out with our chart and break this down. We're going to have shape, and then we will have an area, and an x value, and an ax, and a y value, and ultimately an ay. So starting with shape 1, we have a rectangle that is 72 by 60, or is it 72 this way? Let's check that. So make sure we check that. We've got 6, it's 3. So it's 66 this way by 72. So that gives us an area of 4, 7, 5, 2. So the x distance is just half the distance. This is our origin, remember, right here. So we're just half this distance over. So we said that that was 66. So half of that's going to give me 33. So we're going to take 33 times the 4752. I'm coming up with 156.816. Okay, so y is half the distance this way from the origin up to its x centroidal axis. So that's 30 plus 6 gives us 36. 36 times the area gives us 171.072. And remember your units, you'd have inches squared, inches, inches to the third, inches, and inches to the third. Okay, so we're going to take a look at shape 2. So shape 2 is 24 by 60. That gives us 1440. But since we're going to cut this out, we're going to consider this a negative area or a void area. So we have to think about x a little bit. So we're going from this corner over, half of that would be 12. Well, we got to come over 6. So 6 plus 12 gives us 18 for the x distance from the origin. 18 times the negative area is going to give us a negative 25920. So one of the biggest pitfalls of doing this is forgetting that you got a negative sign here, or when you would do this negative here, you forget that when you're multiplying a negative and a positive, you're getting a negative as well. So you got to watch that. So this has the same y value as the overall because you're up half of this distance, you're 30, and again 6. So that gets us 36. 36 times my negative area is going to give me a negative ay. And that gets me 51840. Okay, so the next shape is shape 3. Shape 3 is exactly the same size, 24 by 60, also a negative void. So we're going to consider that 1440. Now his distance is from this edge over to the center of this. So we've got 6 plus 24 plus 6 plus 12, and that gets us 48. So 48 times our void area gives us a negative 69120. And the y, same as the last y, and in fact they're all the same because we've got a lot of symmetry going on here. So this is 36. And 36 times the area gets you again a negative area, and it's going to be the exact same as the one above it, 51840. So at this point, we're going to sum that column, we're going to sum that column, and we're going to sum that column, and we're going to do it algebraically, so positives and negatives. So you can come up with negative values. It depends on like where the origin is. But in this case, since the origin is extreme lower left side, it should be positive value for everything. Okay, so this, when we do that and consider the negative and positives, I get 61776, and the sum of this column gets me 67392. So to calculate the actual centroid, x bar is the summation of ax divided by a's. So we have 61776 divided by 1872 gives us exactly 33, and that would be inches. And the y bar is the sum of the a y's divided by area, 67392 divided by 1872. And this is 36.00 inches. Now, as we look at this and just think about this, what this is saying is that this thing's coming right through the middle this way and right through the middle this way. So this is your x bar distance, and this is your y bar distance. And you can see that this is exactly half of the total, 33, and this is exactly half of the total on this way. So what you have going on here, because it's symmetric, notice if we had just done this problem without any holes out of it, you would have the same numbers. Now, if these guys would be like, this one would be smaller than that one, or this one would be trucked over here on this side, that would make a difference. But since you've got 6 inches all the way around, everything's symmetric, this is what you should be looking at. So be on the lookout for symmetry, because symmetry is going to be a helpful principle to think about. So that's how you would approach that problem.